So our first searching algorithm is what is known as the linear search. Now, this absolutely positively will net you a result sooner or later, but what I will tell you is it is in no way, shape, or form the most elegant way to actually get things done. So a linear search suggests that as long as I have an array, I have a way to search it. So that means I can go from element to element to element to go through and essentially do discovery, find out whether or not the element is the search string that I'm looking for. So if we are going to look for something like charm, right? Charm starts with a C. We know that it's not here in the letter A's, but we don't have a mechanism to do any skipping. We literally have to go index by index by index and iterate our way through the array until we come to the letter C, until we come to the letter. We are a good long ways off here, aren't we? Yeah, we're a good long ways off. So sooner or later, we'll come through CHART. We've gone too far, and we will find charm has to be on this page somewhere. There it is. There's a lot of charm in here, isn't there? So this is essentially what happens when we look to have a linear search of an array. We're going to go through every one of the different elements in our array, and we are going to continue to iterate until we find the search string that we are looking for. Now, I had mentioned before that this will sooner or later, and it will net you a result, but it's going to take a while. So here, if we look at how many words are there in the English dictionary, there's only 171,476, depending on what year this comes from. And that is not a huge amount when we're really looking at data sciences. If we have hundreds of millions of individual data elements in an array, now you're really looking at an appreciable amount of time. What happens if we're doing some sorting on the indices that Google takes? We have billions of individual indices in our array that we'll have to get to. For individuals at Facebook, we have 3 billion of those we need to get through. Now, that is legitimately going to take time to do individual searches on, right? Because if you're fully aware that your last name begins with W, let's say Wolf, for example, it's going to take, nearly the entire alphabet until we have found that last name. So there has to be something a little bit better than the linear search. And again, the linear search literally goes through every indice to get there. It goes through every element we have in our array until sooner or later, voila, we get to the W. Now we have to continue to search still through, W, W2, W boson, W bosons, W particle, so on and so forth. And that is going to take potentially a very long time. Now, the good news is we have something that's a little faster, and that is next with the binary search of an array.